A giant snowball is melting. The snowball can be modelled as a sphere whose surface area is decreasing at a constant rate with respect to time. The surface area of the sphere is a centimetre squared at time t days after it begins to melt. Write down a differential equation in terms of the variables a and t and a constant k, where k is greater than 0, to model the melting snowball. Initially the radius of the snowball is 60 centimetres, and 9 days later the radius has halved. Show that a equals 1200 pi times 12 minus t. You may assume that the surface area of a sphere is given by a equals 4 pi r squared, where r is the radius. Use this model to find the number of days that it takes for the snowball to melt completely. So I've got the summary of the question here. So let's have a look at it then. The surface area A is decreasing at a constant rate. So dA dt then is the rate of increase of the surface area with respect to time, but it's decreasing at a constant rate, so it's negative k, isn't it, where k is positive. Initially r is 60 when t equals 0, so part B now. So B, r equals 60, t equals 0, and 9 days later the radius is halved, so r will be 30, half of 60, and the time will be 9 days later, t is 9. Show that a is equal to this. So let's separate the variables and integrate then. So here, leave the dA as is, and move the dt up to be with the minus k, and that's separating the variables and integrating. There's a dA on its own, there's always a one lot of something. Integral 1 dA is just a, because you're integrating 1 with respect to the symbol a. Here you've got minus k t, the integral of this, plus a constant c. Okay, so these are our initial conditions. So let's invoke them then, because we've got two unknowns here. So r equals 60. So 60 then is equal to, when t is 0, so it will just be c. But that's not the area. The area is 4 pi r squared. So 4 pi 60 squared is the area, is equal to c. 3,600 times 4 is 14,400 pi. Type it in the calculator if you need to. So there's c. Right, the next initial condition. So we get area is when 30, 4 pi r squared. So 4 pi 30 squared will equal minus kt minus 9k in this case, plus the 14,400, which we've just worked out to be the value of c. 14,400 times pi. So that tells us what k is then. 9k will equal to, move that over there, leave this as is, minus 930 squared times 4 is 3,600 lots of pi, and we've moved that over, so we flip the sign to a minus. 14,000 take 3,000 is 11,000, 400 take 600, it will be 10,800, won't it? Pi. Tap it in the calculator if you need to. So that tells us then that k equals, move the 9 from times down to divide, 1200 pi. Again, tap it in the calculator if you need to. 10,800 over 9 is 1200, so it's 1200 pi. So what do we get then? So a is equal to minus kt minus 1200 pi times t plus the 14,400 lots of pi. So a equals then, take the 1200 pi outside a bracket, and then it will be 12 here, makes 144, 12 12s, 144 hundredths, minus, and then it's just a t, isn't it, here. Now we can do part 2, which asks us how many days for the snowball to melt. Part 2, a equals naught, which is when it melts, when T will equal, we'll put 12 in, 12 days. And you get 0 surface area, which is what it takes for the snowball to melt completely.